Now this is the third video of your chapter ratio and proportion. Now in this video I'm taking up the second exercise, and I told you I'll be starting up with the proof of the questions. Now in question number 13th you have been given that B is the mean proportion between A and C. If B is the mean proportion, I told you to write, it means it is given that B square is equals to AC. If B is the mean proportion between A and C. Now what you have to prove? You have to prove that AB plus BC is the mean proportion. So it means you have to prove that AB plus BC whole square is equal to A square plus B square into B square plus C square, which is the product of the two terms given to you. Now with the help of this given, we are going to prove it. Now I'm taking up the left hand side. Same you have to do in other questions also. Take the left hand side first and note it down. In this I can take B common. It will be A plus C whole square with B also. Inside the bracket I am taking B common. Now this square will be given to B also. It will become B square A plus C whole square. Now value of B square is given to you as AC. So I can write it as AC. A plus C whole square. Now this is your left hand side. Now I'm going to write the right hand side. Right hand side is A square plus B square multiplied with B square plus C square. I'm going to prove both the sides same. Now it is A square plus, for B square I can write it as AC, and in the next also B square I can write it as AC. Now in the first binomial I can take A common. It will be A plus C. In the second binomial I can take C common. It will be A plus C. A and C multiplied becomes the two monomials, when multiplied becomes AC, and two binomials will become A plus C whole square. This is equal to your left hand side, as you can compare and see. So you will write this is equal to your left hand side and hence proved. So this is how you have to take the left hand side, come up till the last step and take the right hand side. Right hand side should also have at the end the same solution as you have for the left hand side. This shows that we have proved it. The questions of mean proportion, in all the questions of mean proportion, you are going to take it like this also, that square of the mean proportion is equal to product of the two terms. Now I am taking up 16th, 17th, 18th, 19th. They are based on the same pattern. Now I am taking I am taking up the 17th question. What the question says? That A upon B it is given that A upon B is equal to C upon D is equal to E upon F. This is given to you. And I am going to take it as let. You are going to write let A upon B is equal to C upon D is equal to E upon F is equal to K. This is called the K method for doing the proofs. Now if I take all equal to K, from here E becomes equal to Fk, C becomes equal to Dk, and A becomes equal to Bk. Now I'm taking the fourth part. This is the 17th question I'm taking. In the 17th question I'm taking, and its fourth part I'm doing. In the fourth part, the left hand side is BDF A plus B upon B plus C plus D upon D plus E plus F upon F and its cube. I am taking the left hand side. So wherever you find A, C, E, replace by its value in terms of K. So you are not going to do anything with BDF. In place of A, write BK. It will become BK plus B upon B plus, in place of C, I will write DK. DK plus D upon D. Then in place of E, I will write FK plus F upon F, and cube is given to you. It will again become BDF. From this I can take B common, K plus 1 upon B. The next I can take D common, K plus 1 upon D. Then I can take F common, K plus 1 upon F to the power 3. Now this B cancels out, D cancels out only after taking common. F cancels out. You are left with BDF. You are left with K plus 1 from here. Again plus K plus 1. Again plus K plus 1 whole cube. This is equal to BDF. How many K's are there? 3K. How many 1? 3 whole cube. Now from here I can take 3 common. It will be K plus 1. Now this give cube to 3 as well as K plus 1. What it will become? BDF. 3 cube will be 27 and K plus 1 whole cube. So finally what is, again I am writing your left hand side. Finally what is your left hand side? Your left hand side is BDF into 27 into K plus 1 whole cube. Now I'm going to take the right hand side of your proof. What you have in the right hand side? Right hand side says it is 27 A plus B, C plus D and E plus F. This is equal to 27. Instead of A, what I can write? BK. As I told you, you can replace ACE by BK, DK and FK as we have done in the left hand side. C I will replace by DK and E I will replace by fk. It will be 27. From here you can take b common, k plus 1. Then you can take d common, k plus 1. Then you can take f common, inside the bracket k plus 1. All are multiplied. So it will be 27. B, how many monomials? B, D and F. B, D, F. And how many k plus 1? 3. So it will become k plus 1 into k plus 1 into k plus 1 will become k plus 1 whole cube. So this is equal to your left hand side. If you want, you can compare also. See, this is what I have done it in your left hand side. That left hand side is BDF into 27, or I can write 27 before also. 27 into BDF k plus 1 whole cube. So this is how you have to do the proving by the K method. Now in the 22nd question and in some other questions also, in 23rd also, it is given that A, B, C or A, B, C, D are in continued proportion. If three numbers are given in continued proportion as A, B, C, then you can use the same as we are using for the mean proportion. If A, B, C are in continued proportion, it means B square is equal to AC. Now I'm taking the 22nd question. In the 22nd question, you have been given that A, B, C are in continued proportion. So I will write A upon B is equal to B upon C. You can also do by B square is equal to AC, but I am doing it by the K method. For that you will write A upon B is equal to B upon C is equal to K. So from here B will become CK and A will become BK. Now in continued proportion you see that B is repeated. So A, I can again change it by putting the value of B as CK in this. Replace this B by CK. It will become CK into K, that is CK square. So for B you are going to write CK and for A you are going to write CK square. I am taking the sixth part. In the sixth part of your 22nd question, the left hand side is A plus B plus C into A minus B plus C. So as I told you, instead of A, I will write CK square. For B, I will write CK plus C. In the same way, in the other trinomial also, CK square minus CK plus C. Now you can take C common, K square plus K plus 1. In this also you can take C common, K square minus K plus 1. Then C into C will become C square. And you will have these two trinomials. And we'll have to solve it further also. Because in the right hand side of the proof, you see that there is no subtraction sign. But we have the subtraction sign in the left hand side. So we have to do further solving for it. I am rearranging it. I am writing K square plus 1 plus K. And the other trinomial as K square plus 1 minus K. It will be C square. This I am going to take as A B as K as B. So it will become A plus B. This I have taken as A, K square plus 1. This I am taking as B. It will become A plus B, A minus B. And you can write the formula of A plus B into A minus B. What it will become now? A square. Product of it will be A square minus, because this is plus and this is minus. It will become A square minus B square. What will you have? C square expanded by the formula A plus B whole square. It will be what? K square. K square square means K to the power 4 plus K square twice K square twice AB plus 1 minus K square. And what it will become? And what it will become? It will become C square K to the power 4. 2K square minus K square will be plus K square plus 1. 2K square minus K square. This is your left hand side. Now I am taking the right hand side. Right hand side it is A square plus B square plus C square. And for A square I will write it as CK square whole square. B square will become CK whole square and plus C square. It will become C square K4 plus C square K square plus C square. Take C square common. K4 K to the power 4 plus K square plus 1. This is your right hand side. Now this is equal to your, if you compare, you see that right hand side is the same as the left hand side. Left hand side also you have C square in the bracket K4 plus K square, and see the right hand side. You find it the same. So this is how you are going to do the proving. I have shown one part for you, the other you will do. Now I'm going to show how to start up with the 23rd question. In the 23rd question, again it is given that A, B, C, D are in continued proportion. If they are in continued proportion, how will you write? A upon B is equal to B upon C is equal to C upon D is equal to K. By writing let, you have to write over here let. C becomes equal to DK, B is equal to CK. So for C, replace this C by writing its value as DK. DK into K, it will become DK square. So C will be DK, B will be DK square, and what is A? A is BK. From here you see A is BK. And replace the value of B by D square. D square into K. It will become DK cube. So value of C will be DK. Substitute B as DK square and substitute a as dk cube in your proof. So on all the proof, replace the value of a, c, a, b, c with dk cube, dk square and dk. And you will get the proof as I have done the questions, shown the questions to you. So finish up with exercise 7.2. Now in the next video, I'll tell you how to solve exercise 7.3.